Solving simultaneous equations by substitution. In the previous video, we looked at solving simultaneous equations by sketching the graphs and finding the point at which the two lines meet. We also used substitution to prove that what we drew was in fact correct and that the coordinates were equal to each other. Here, we're going to show how you can solve two equations without having to draw a graph. In this first example, you'll see I've got two equations. One that says 3x plus 2y equals 6, which I will label as equation 1. And we've got x equals negative 5y plus 2, which I'll label as equation 2. What I'm going to do is I'm going to go and I'm going to substitute equation 2 into equation 1. What do I mean by this? Well, when we're solving linear equations, we can only solve one letter at a time. In other words, because I've got two letters there, I can't solve it. I can't solve it unless I reduce the number of different pronumerals or variables that there are. So, follow me. I'm going to substitute equation 2. You'll notice here I'm just writing 2 because I know what I mean. That's why I like putting those little labels. It saves me writing a heck of a lot of rubbish. So, I'm going to substitute equation 2 in equation 1. What does that mean? What that means is I notice that whenever x here can be also rewritten as negative 5y plus 2. In other words, every time I see an x, it's the same as negative 5y plus 2. So that's exactly what I'm going to do. I'm going to substitute in this first equation. So 3, negative 5, you'll notice here I've got all my lovely colours so that I remember what I'm doing. Plus 2y is equal to 6. I'm going to expand these brackets, get negative 15y plus 6 plus 2y is equal to 6. Negative 15y plus 2y gets us negative 13y. Pause for effect. So negative plus 6 is equal to 6. So then I just need to take away 6 on both sides. And I get negative 13y is equal to 0. And then if I divide both sides by negative 13, 0 divided by negative 13 will be equal to 0. See down there. So now to find out what the value of x is equal to. So what I'm going to do is I'm going to substitute y is equal to 0. Now I could actually choose in any equation I like. Probably the easiest one to do will be to substitute it into equation 2. So that way I definitely have an answer. So I've got x is equal to negative 5 0 plus 2, x is equal to 2. So the solution is equal to 2, 0. Or in other words, when x equals 2, y equals 0. You may go and put either one of these as your answers. You don't need to write the whole kit and caboodle as I've done there. I just want to demonstrate two possible ways of answering it. Now you'll notice there I substituted y equals 0 into equation 2 as an additional proof. I'm just going to substitute it into equation 1 just in case you wanted to demonstrate it. So 3x plus 2, 0 is equal to 6, or 2 multiplied by 0. So 3x equals 6, divide both sides by 3. You get x equals 2. So, in this second example, we'll notice here we haven't got a very convenient, x equals blah, 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 in order to substitute, or y equals equally blah, 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 blah. So we'll have to make sure that we can turn one of these equations into a blah, 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 in order for us to solve it, blah, 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 being the, of course, technical term. So what I'm going to do is I'm going to rewrite one of these equations, I'm going to choose equation 2 here. I'm going to make x the subject. And that just means making, if you ever see the phrase the subject, that means it's x equals blah, 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 blah. That's what the subject means. And this is going to be, I'm going to label this equation 3. So 2x plus 3y is equal to 6. 2x is equal to negative 3y plus 6. X is equal to negative 3 on 2y plus 3. And this is going to be equation 3. Now I'm going to sub equation 3 into equation 1 here. Now the reason I've chosen equation 1 to substitute it in, because you may have heard me say, well, it doesn't matter which ones we can do, we could just substitute into anything we like. Well, if we substitute it back into equation 2, we're basically substituting the same thing, because equation 2 and equation 3 are actually identical. The only thing is I've just rearranged it slightly. So it would be like saying, I'm going to substitute the number 4 for the number 4. Or the number 5 for 10 divided by 2. Well, they are the same thing. So we're going to substitute this into equation 1. And I know it's got a scary fraction in it, but trust me, the fractions will not bite much. So 3 over negative 3y over 2 plus 3 is equal to negative, oh no, slow down, boyo, it's 14. That's what we need to do. Oh, and there should be a plus 2. Oh, I'm just daydreaming here, forgetting everything, getting far too excited. So I've just replaced every time I see the letter x with this little expression here, and plus 2y equals 14. So we're going to expand these brackets and get negative 9y over 2 plus 9 plus 2y is equal to 14. I'm going to minus the 9 on both sides, and I get myself a thing, negative 9y over 2. I'm just going to replace this 2y to make it all the denominators the same. This is going to be the same as 4y over 2. 14 take away 9 is going to make that a 5. So negative 9y plus 4y over 2 is going to make that negative 5y over 2 equals 5. So what we can do here, we're trying to solve this, so we'll divide both sides by negative 5 over 2. Get rid of that y. Oh no, just smudged it, everything. Negative 5 over 2. So now it becomes y equals 5. Now 5 is the same as saying 5 over 1. Divided by negative 5 over 2, which, if you know your fractions in the laws of dividing fractions, is going to be the same as times 2 over negative 5. The 5 and the 5 cancel out, and we just get 1 times negative 2, which is negative 2. Now what I'm going to do, hooray, we've got y equals negative 2. So now I need to figure out what x is. So I'm going to substitute y equals negative 2. I'm going to choose equation 2 this time because we've already done lots with equation 1. Doesn't matter. No. So I get 2x plus 3 negative 2 equals 6. 2x minus 6 is equal to 6. 2x is equal to negative 6 and 6, so we're going to add 6 on both sides, and that's going to be 12. X is equal to 6. So therefore the solution is at 6, negative 2. Hooray, go us. And that's how you solve by substitution.